Hello everyone. Today we're going to be presenting our microcontroller project. So we're doing radar and some buzzer detection using processing, the app, and C programming for our codes. For the concept of our project, so we want to create a radar, right, that can detect, something, some foreign object, some adversary, some random people or an object, some weird stuff. And then we will be activating if it, detects something. It will cause a buzzer to alarm and go beep, 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 very loudly when anything comes near. Now, when anything comes near, we, in the concept, in our brain, we basically change the variable for the distance to be fixed, so you can change it, and then we can use this detection for things like a car alarm, when you're near walls, you get close to it, and our servo will rotate 10 degrees until it reach 180, and then when it reach 180, it'll go to zero, and then it'll go to zero, and then it'll go to negative 180 degrees, stuff like that. But in our demonstration, we'll be doing 5 degrees, even though it's a bit dangerous. It is very dangerous. 5 degrees is gonna break our servo. It's going nuts. And when the sensor detects something, it will cause an alarm, which I already said. And so that's our concept for our project. Now we're going to be talking about a circuit and code. So now we will be looking at the circuit first. Now let's see what the requirements for our fun project is going to be. Now for our requirements, we're going to be needing a board, a buzzer, servo, an also sensor, Arduino IDE application. This is where we write the code, and then processing application for imagining images. The processing application, we already see the cool radar stuff. So these are all the requirements. Let's go on to the next slide. Now we talk about a circuit diagram of our project. So we have an Arduino board, and then we have the servo and the sensor with a attachment of some noise buzzers. So for this diagram, we could see that we connected the servo with the sensor, which in this diagram it cannot connect. But if you can create in real life, we can actually stick the sensor on top of the servo so it can actually move. It's a bit not durable because it loves to fall apart. But if you don't go too crazy with the degrees, then it will be okay. So we connected everything to the circuit. So we connected some circuit to our voltage to the ground, yes. And then we connected some activations. Now this will be used in the code later. And the other part is the buzzer. So the buzzer in this diagram is not our buzzer. As you can see here, we don't really have the activation for the IO port here. We don't have IO port for this diagram. So we add our IO port of our own. It'll be green. And then we're going to add our voltage and ground. So that's it for our circuit diagram. Let's go on to the next part, the code itself, the big code. Now we're going to talk about our IDE code in C. This is our IDE application for C. We can connect this using our Arduino board. As you can see here, it's not too long. It's not too long at all. So we have our pin mode for trigger pin, we have pin mode for echo, and for bus pin. Now trigger pin, echo, and bus, we all know what it is. Bus pin is beep 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 beep, the buzzer. Trigger pin is where it triggers. So we change something to output, input, output. Reasonable, like the buzzer is output. Yeah, that's an easy example. And also we'll be changing the right pin for an active low buzzer. Active low buzzer, if it's high, it doesn't produce a noise, which okay. And also you can't change the how much sound, which is it's gonna be the same sound. Beep 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 beep. It's annoying. but let's go on to the next part. We have read distance. This is where it will read, how far the buzzers go. When the buzzer it goes shoot, right? It shoots, and then it will record the distance in centimeters, which is a bit long. The centimeters are long, yes. And then we will have our calculations over here. Not too crazy. It's just shoot, 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 shoot. And then we will now have the detection. This is where our code forms, where our big important stuff comes. You can see here our angle. In this example, we're going to do plus minus 5. In the previous page, it's 10, but let's be a bit more risky and do 5. Yes, it's going to be a bit janky. It's going to broke itself apart, but that's fine. Plus minus 5, because it can detect a lot more. You can calculate the distance, and then it will output if you have the output, which output the angle. What's the angle? What's the distance? Basically, what is it at this moment? What's the angle? What's the distance at this moment? That's what all of this is. Also, we have if distance, and distance is in this range right here. So it's too close. This is where we have our fixed parameters for our distance. If it's between this, it will go beep 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 beep, and we're like too close, and we delay it. This is also the same. The only difference is just it's the angle. So there's not much difference in here. So one cycle, and then this code right here is the other cycle. Reasonable.
So hello, this is the code in the processing program. So as said in the previous slide that the code from the IDE Arduino that have been uploaded into the Arduino board, it will return the number of strings in the set like 110 per output. So this processing code right here is the code that we use to receive the output and then display it in the radar diagram. So the first part of the code is the my port, which is we use to set up the port that it will receive the information from. It is the same port that we plug in the Arduino board. And then we have the angle distance and the timestamp. It is the variable that we use to receive the information from. And then we have the setup method, which is another port setup. And we choose the zero here because we use COM3 port. But if you use a different port, you can change it. And the next one is drawn. The draw port is we use to draw the diagram in the empty screen. So right now the processing program will output the empty screen. So we use the draw port to draw the half circle in the green color. And then we draw a sweep, which is the line that will go for the each turn that the Arduino board has made. And then we have the for loop like that with the if condition to draw the red circle when the device detects something which has the 3-second lingering delay. And then the info part, which is the display of the number of the angle and the distance right now that it has been detecting. And after that, the serial event, which is how we receive the data from the board. So we read the string that we receive from the Arduino board and then assign it to the incoming data. And then the incoming data enter the if-else function to check if the received output have like the two sets of the program. And then we assign the first part to the angle variable and the second to the distance. And then we use it to run the red circle that we use to detect later on because it uses the same variable. So this is what it looks like in the processing part. So when we activating the Arduino board, which is when we plug in the Arduino board, the servo will automatically turn itself in the angle like this, and then the left screen, the left picture is the output from the processing program, which you will draw a half circle in the radar like that, and then it will display the angle and the distance. And the red dot right there is like when it detects an object in the close distance, it will draw the red circle with the 3-second delay. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this is another demonstration that it will look like when we zoom out from the device. And this video is the example that we took for the inspiration for our project. Finally, our contribution that we have added our own spin from the project. So firstly, we have added buzzer to play the sound alarm if anything comes close, and then we change the motor degree so that it can be used in other sort of computers, and we change the IDE code to avoid the sensor timeout, and also change the radar in the processing to make the computer more variable. And we also change the 5 degrees scanning that can cause a gap in the radar, so we replace it with a dot instead. But still, it has a similar functionality. So thank you for watching our presentation.